Objective: to study the effect of heat on ferrous sulfate crystals. Materials required: ferrous sulfate crystals, dilute hydrochloric acid, sodium hydroxide solution, acidified potassium dichromate solution, filter paper. Apparatus required: test tube, beaker, pestle and mortar. Basic principles. Crystalline ferrous sulfate is a hydrated salt. Hydrated salts, in general, lose water of crystallization on heating at low temperature. On strong heating, the anhydrous salts decompose to form the corresponding oxide. The effect of heat on ferrous sulfate crystals can be described by the following reactions. FeSO4 7H2O on heating at 300 degrees centigrade gives FeSO4 plus 7H2O. 2. FeSO4 after strong heating gives Fe2O3 plus SO2 plus SO3. Fe2O3 is an insoluble amphoteric oxide. It dissolves in both acids and alkalis. Fe2O3 plus 6HCl gives 2FeCl3 plus 3H2O. Fe2O3 plus 2NaOH gives 2NaFeO2 plus H2O. Procedure: grind the crystals of ferrous sulfate to fine powder in a clean pestle and mortar. Take about 2 to 3 grams of powdered ferrous sulfate salt in a test tube. Heat it on a low flame until no more water vapor are given out. Water droplets are seen in the upper portion of the test tube. Water of crystallization is lost. Color of the salt changes to white. Anhydrous ferrous sulfate is formed. Heat it strongly and observe the changes. Colorless and suffocating gas having smell of burning sulfur is evolved. The color of the solid changes from white to red. Test the evolved gas with a paper dipped in acidified potassium dichromate solution. Yellow color on paper changes to green. Gas evolved contains SO2. Divide the red residue left in the test tube in 2 parts. To 1 part, add dilute hydrochloric acid and shake. The red residue dissolves to give yellow solution. Fe2O3 formed dissolved in dilute HCl to form ferric chloride solution. To the second part, add NaOH solution and shake. Warm it if required. The red residue dissolves in NaOH solution. Fe2O3 reacts with NaOH to form a colorless solution. Results: crystalline ferrous sulfate is a hydrated salt. On heating at about 300 degrees centigrade, it loses water to give white anhydrous ferrous sulfate. On heating strongly, anhydrous ferrous sulfate decomposes to give ferric oxide. It is red colored and insoluble in water. Fe2O3 reacts with both acids and alkali. Therefore, Fe2O3 is an amphoteric oxide. Conclusion: heating of ferrous sulfate crystals is a decomposition reaction or thermal decomposition reaction. Precautions: use ferrous sulfate crystals which are light green in color, having no brownish or yellow deposit on their surfaces. While heating powdered ferrous sulfate crystals, keep the test tube sloping downwards. Heat on a low flame around 300 degrees centigrade, initially till no more water vapor is given out. The test tube containing the reddish residue should be cooled to room temperature before proceeding further.